All right, so an object is dropped from rest from the top of a 200-meter cliff. Air resistance is negligible, and we want to know how far it falls during the first 3 seconds. This is one where they give you some extra information. You don't care about the 200 meters. And so I'm going to use the 1/2 gt squared equation. You notice what I'm doing here is I'm solving this the way you'd be expected to on the AP in May. So I'm not even hunting for formulas. I have these memorized. So I want you to actually look back and figure out where I got 1/2 gt squared from. Like what formula did I grab and what things were equal to 0. And so I'll put in 10 here. So 1/2 times 10 is 5. And since I'm doing this for 3 seconds, that's 3 squared, which is 9. So 5 times 9 is 45 meters. And that's how I'm getting the answer to number 6. For number 7, a rock is thrown at an angle, and we want to know what the acceleration and vertical and horizontal speeds are at point P. So we can actually rule out D and E, since at point P it stopped in the vertical direction. We know that there's always an acceleration of G. And so what that leaves us with is choice A, because our horizontal speed never dies out until it hits the ground, and we're not studying the problem anymore, because we always have that constant V0 cosine theta. Now, the acceleration is just going to be at point Q. Let's be clear, we always have an acceleration of G. And the horizontal speed is going to be V0 cosine theta. And at point Q, when it's returned to its original altitude, the speed will be V0 sine theta in the vertical direction. So that's how we get choice D. Now, for number 9, an object is shot off the roof. We want to know the time between the object leaving the roof and hitting the ground. So we're going to have 10 is 1/2 g, which is 5t squared. And so the time is going to be square root of 2 seconds when we isolate t. And then the horizontal distance, that's going to be distance is rate times time, since it's the horizontal distance we're worried about. So it's going to be 5 times the square root of 2, which is choice E. Okay. Now for this one, we know the acceleration at 2 seconds, so we take the second derivative. So the first derivative is 6t minus 2, and the second derivative is just going to be 6 meters per second squared. So this I get from the second derivative. And my pen tool is not working, so I'm going to have to abbreviate this. All right, so that is the answer to number 11. We'll begin free response question number 1 in the next video.